Hi there, welcome to this video. This is 2-2 and we're going to talk the alternate limit definition of a derivative. Essentially, how do I find a derivative at a point using a limit? Now it's important to note the multiple choice applications of this question are more applicable to the AP exam, but we're going to run through how we exactly do this without a multiple choice, and then I'll set you guys up for future lessons about how this is viewed through the multiple choice lens. Lastly, we'll go ahead and view how to find derivatives using a calculator. I'll do TI Nspire as well as Desmos, so stay tuned for that. Okay, the alternate form of the limit definition of a derivative. In the previous video, we went ahead and found how to find a general derivative of a function. So I could plug in an x value, and that's what it was. We do have the derivative of at a single point called the alternate form of the limit definition, and here it is. It is f prime of c, again c is a specific x value that you're going to plug in, is equal to the limit as x approaches c of f of x minus c over x minus c. And an easy way to remember this is kind of the limit, format generally sets it up, right? The limit as x goes to c, both, your outputs on top over your inputs. And we talked about how that's connected to the average rate of change. So let's go ahead and look at a specific example here. We have g of x is equal to x squared minus 2x plus 1. Find g prime of 4. Okay, so they wanted a specific value. So g prime of 4, I guess I should start with that. G prime of 4 is equal to the limit as x approaches 4. And then here is my format. I'm going to have f of x minus f of 4 all over x minus 4. Now, we're going to have to do some lifting here. I'm going to have to plug in my function, but this is kind of nice because I don't have to plug in the x plus h. You don't have composition, which is nice. I do have to find g of 4, so I'm going to go ahead and evaluate 4 squared minus 2 times 4 plus 1. So what does that give us? 17 take away 8, I get 9. Hopefully I did that right. Over x minus 4, not 3, x minus 4. So if we go ahead and consolidate this, we get x squared minus 2x minus 8, which I feel like in this format you guys are more comfortable in now evaluating this limit. So if I go ahead and do this, I'm going to factor. So the limit as x approaches 4, I get x minus 4, x plus 2, and we know that our x minus 4s cancel. If you were to evaluate at this stage, if you were to evaluate and plug in 4 here, you would get 0 over 0, you would get an indeterminate. So again, you have to factor in order to evaluate this limit as x approaches 4 of x plus 2. And if we plug in 4, we get 6, which is pretty cool. That should match the previous problem. If you look back on the front side of your notes, that will go ahead and match that. But that's the instantaneous rate of change. That's the derivative at 4 of this function right here, x squared minus 2x plus 1. Okay, so here is a practice problem. Please go ahead, pause me. I want you to try this, and I'll kind of release this in stages, just kind of checkpoints to see if you're setting it up correct. So go ahead, pause me, set this one up. Okay, hopefully you paused. Here is again, the setup for this. So I want h prime of 2. That's going to be equal to the limit as x approaches 2 of, again, here it's going to be not f of x, it's going to be h of x minus h of 2. So it's always your function minus the function at that value, and in the denominator, your x value minus the x value, 2. Okay, so hopefully you had that set up. Again, go ahead, fix anything if you need to, and pause me. I'll review the rest of the answer here. Okay, now let's go ahead and substitute in our values. So I have the limit as x approaches 2. Here my function h of x is x squared minus 1 minus h of 2. h of 2, if I plug in 2 into my function, x squared minus 1, we get 3. So we'll subtract 3. We get x minus 2. And we'll go ahead and kind of clean this up. Pause me if you made any errors, and then we'll go through the rest of the answer. All right, so hopefully you went and got x squared minus 4, which we know we can factor relatively easy. This gives us x plus 2, x minus 2, and so our x minus 2's cancel. There we go. If you ever get 0 over 0, it's indeterminate. I can't do anything with it. You have to find another way in order to evaluate. So the limit as x approaches 2 is equal to 2 plus 2, which is 4. It is 4. So that's the derivative of h at 2. Pretty cool, huh? Okay, so yes, this is a lot of notation. The notation's arduous, right? You're like, oh, do I have to write the limit every single time? Yes, until you do not have an x value. I guess here I could have dropped it here. I didn't need it here. Until you have no more x's, you have to keep the limit statement. And then there's lots of algebra going on here. So there is an easier way to find derivatives, and we will get there. But how does this apply on the AP exam? Well, it's oftentimes visualized in multiple choice problems, and what you need to do is you need to be able to recognize the structure. So here's an example. What's the limit as h approaches 0 of x plus h squared minus 2 times x plus h minus x squared minus 2x all over h? Well, sometimes they're not even factorable. So what your brain needs to be able to do is say, hey, this is a derivative. This is f prime of x. So what you need to be able to do is say, what's the function I'm working with? Well, based upon the last video, and you can see how this could apply to what we just talked about in the alternate limit, is you need to be able to identify the function. So on this one, it just says, what's the function in this setup? And it's easy. It is x squared minus 2x. So pretty straightforward. We'll continue this again in the future, what we do with it. But the same idea here. The limit of this is going to be equal to f prime of x. So if this is the f prime of x, then what's the function that we have? Well, again, this is the location of the function, okay? So this is going to be sine of x. And I can go ahead and kind of draw up something similar. Like if I said, what is the limit as x approaches 3 of sine of x minus sine of 3 over x minus 3? What is this? Well, your brain needs to be able to say, hey, this is f prime of 3. So what's my function? Sine of x. And again, so what do I do with that? We'll get there. We'll get there. Okay, so one thing that we covered in this video, the alternate form of the limit definition. So you need to be familiar with this format in addition to the limit definition derivative, which is right here. Okay, and we'll talk about in the future how we use those. Now let's go to technology. How can I use technology to help me approximate instantaneous rate of change, also known as the derivative, with a calculator? So I'm going to go ahead and first start out with the TI Nspire. So if you have that, please go ahead, take out your TI Nspire. And what we're going to do is show you how to take a derivative of a function. The first thing I like to do is I like to define a function in a graph. I always tell my students, just define it in a graph, because sometimes you need the picture, sometimes not, but either way, it stores it in your calculator. So the function that we're working with in example 5 in the notes is the natural log of x to the power of 3, and we add 11, plus 11. So here's my function. They call it h. So here's h. Okay, beautiful picture. And what I want to do is I want to take some derivatives. So I'm going to go to my calculator. I'm going to add a page, so control doc. I'm going to add a calculator, and let's take a derivative. A couple of ways you can go ahead and take a derivative. One is to click menu. We're in calculus, so go to calculus, and we want a derivative at a point. Note, if you have the CX version, if you do not have the CAS, the computer algebra system, you do not have general derivative. You'll just have derivative at a point, which is what we want. So derivative at a point, the value in example A is -1. So I want, what is h prime of -1? First derivative, yes, it is possible to have more than one derivative, but we'll stay at the first derivative for now. And this says, hey, what's the derivative with respect to x? We'll talk about notation later on, but this is the derivative, and they're saying of what function? What? So I'm going to hit VAR, and I'm going to use the defined function that is there. So f1 of, and they're saying, hey, what's the input variable you want? Let's use x. And they say it's at x equals 1. So we hit enter, and we get 0.3. So 0.3. Okay? So there you go. That is how you do derivative at a specific point. And we can do this again, right? The next one they want is at 0. So look, I could scroll up. Boop. I could just go up and then hit enter, and it just copies it down. And I don't want at -1. I want it at 0. So I enter that. And that answer is 0. Nothing exciting. I need to change that one so it's more exciting. Okay. Next part, C. What's h of 4? Pay attention to notation. They're trying to catch you off here. This is h prime. This is h of 4. They just want the function value at 4. So I'm just going to go VAR. Here's my function. And I want it evaluated at 4. So we get that value, 4.317. Okay. And then lastly, we have h prime of 5.1. There is another way to go ahead and take a derivative. It's next to this book right here, this icon. You have so much stuff going on right here, but you'll see the notation for a derivative right here. So it's right here. This is the first derivative. And we kind of need to talk about notation. The derivative, this is just your input variable. Like what derivative are you taking what variable are you taking the derivative with respect to? And it's going to be x. So we say d dx. And again, I'm going to put my function in, and I want the value. So the value, no, sorry, it's x, f1 of x, the derivative of f1 of x. And then what we have to do at a point is we have to go ahead and evaluate at a specific point. So I don't even know, I'm like freezing up. How do I do this? Let me figure this out. Okay, I found what I was looking for. So in order to tell your calculator, hey, I need to evaluate this derivative at a certain value, you need a long bar right here, and that is found underneath, it's a secondary function to the equal sign. So you hit control equals, and then it's right here. So you enter that, and then, or you can use on your keyboard shift, and then I think that is what, backslash? Shift backslash is also the vertical line. And then we just say, okay, at what x value? X equals 5.1. And I hit enter, and there is our answer, 0.543. If you ask me, doing the menu calculus derivative at a point is much simpler than all that, but to each their own. Okay? All right, so that is with a TI Nspire, and there's our values. The last one that I wanted to go ahead and show you is how do I do this in Desmos? How do I use Desmos? And Desmos, quite frankly, is kind of easier to work with. So let me go ahead and show you. We have a function called k, and they want these values. So in Desmos, you can go ahead and open up a Desmos graphing calculator. You're going to define your function, similar to what we do in the TI Nspire. Okay, I'll call it k of x. Equals, it's a rational function, so I'll hit my divide button to get a function, and I want the square root, was our function, the square root of 3x plus 8. And in the denominator, we had 1.2x plus e to the x. So again, e to the x, you can go down here into functions and find exp, or you can just literally type in the function e to the power of x, okay? And it'll graph your function. Pretty cool, right? So now I want the derivative. Okay, well, just use math notation. K apostrophe, we enunciate that k prime, of -2, and boom, there is our value, -0.837. Okay? What if I just want a function value? Like, what's k of 1? Well, type it in. It will give it to you. K of 1 right here is equal to that value. Where's my x? Oh, 1's right here. 0.846 according to this here. Okay? So, go ahead, pause the video. I want you, oh, that's my daughter. I want you to find these values, and then unpause. Okay? All right. Try those. I'll show you the answers. All right, hopefully you paused the video and tried these. Here's your responses. These are your outputs and your answers. If you struggled with pi, k prime of pi, pi is located right down here on your keyboard, but pretty cool, in Desmos, you can literally type p and then I, and it changes it to pi. So Desmos, pretty awesome. Here's the responses. Remember, always 3 decimal places, rounded or truncated. Okay, I hope you learned how to use the alternate limit definition of a derivative to find the derivative at a point, as well as how to use technology to find derivatives. Catch you in the next video. Give a thumbs up and a subscribe. See you later. Peace.